Hello all, I am Disha Shukla and welcome to the session. Now, in the previous session, we have saw what is spread spectrum and what is the direct sequence spread spectrum technique. And we also came across the near-far effect, wherein the near-far effect was the basic disadvantage of DSSS. So, to overcome that disadvantage, we have the another spread spectrum technology called the frequency hopping spread spectrum, and that we are going to discuss in this session. So, frequency hopping spread spectrum is a robust technology with only very little influence from the reflection, noise and other environmental factors. The active system numbers in the same geographical area is higher than an equivalent number from the direct sequence spread spectrum systems. Thus, it is suited well for the installations designed to cover the large areas where numerous co-located systems are needed. They are also used in the cellular developments for fixed broadband wireless accesses where the direct sequence spread spectrum cannot be used. A variation of frequency hopping spread spectrum is the adaptive frequency hopping spread spectrum that involves resistance to the radio frequency interference by avoiding crowded frequency in the hopping sequence. Now, a frequency hopping spread spectrum, the frequency here is constant in each time chip. Instead, it changes from chip to chip. Frequency hopping systems can be divided into fast hops or the slow hops. A fast hop FH, that is frequency hopping system, is the kind in which hopping rate is greater than the message bit rate, and is the slow hop systems, the hopping rate is smaller than the message bit rate. In frequency hopping systems, the transmitter changes the carrier frequency according to a certain hopping pattern. The advantage is that the signals sees a different channel and a different set of interfering signals during each hop. This avoids the problem of failing communication at a particular frequency because of the fade or a particular interfere. Frequency hopping spread spectrum or FHSS is a method of transmitting the radio signals by shifting the carrier across numerous channels with pseudo-random sequence which is already known to the sender and the receiver. Frequency hopping spread spectrum is a robust technology with only very little influence from the reflection, noise and another environmental factors are also affecting it less. The active system numbers in the same geographical area is higher than an equivalent number for a direct sequence spread spectrum. Thus, it is well suited for installations that are designed to cover a large area with numerous co-located systems. They are also used in the cellular developments for the fixed broadband. Now, in a FHSS, that is frequency hopping spread spectrum system, the transmitted signal is spread across multiple channels. The full bandwidth is divided into number of channels centered at F through starting from F to Fn. The signals hops between the whole sequence. Now, as you can see in the figure, we have the original signal and we have a spread signal. Now, what does the modulator do? The modulator has a frequency synthesizer that tells it at which frequency it needs to go. That frequency synthesizer gets an input from a frequency table, and again the frequency table gets an input from a pseudo random number generator. Now, this will be more clear from the next figure. Now, here as you can see that we have a whole bit pattern, that is a pseudo number generator, and along with that we have a frequency table here. So for the first value, that is 101, it is directly seen in the frequency table's k bit column. Now in the k-bit column 101 is found, and related to it is the 700 kilohertz. So the 700 kilohertz will be sent to the previous, as we have seen here, in the frequency synthesizer, and using that the original signal is modulated. Now after 101 we have 111. So again, looking into the frequency table, we will find where is 111. Now for the 111 k-bit value, we have 900 kilohertz associated frequency. So again the 900 kilohertz will be sent to the frequency synthesizer in this figure that we have, and that will, the original signal will now be modulated using the 900 kilohertz. Again, looking at the k-bit pattern, we have 001. Now searching it in the frequency table, we have 001 with k-bit here, and the associated frequency is 300 kilohertz, right? So now the 300 kilohertz will be sent to the frequency synthesizer, and using that frequency the original data will be modulated. Now this is the whole figure, this is the whole way that a frequency table runs, or the frequency hopping works. As in, using the pseudo numbers that we get, we find the associated frequency with it, and then the whole signal is modulated or is hopped to that particular frequency. Here, because the frequencies keeps changing as the k-bit pattern changes, hence it will be hopping to different frequencies, and hence the name frequency hopping spread spectrum technology. Now this is the way in which we have just shown the graphical view, wherein we have seen that how the at different hop periods the frequencies are mapped. And this is how the frequencies versus time graph would be in the FDM, that is your frequency division multiplexing, that we have already seen, wherein each user was given certain frequency range, and he or she can transmit the data in that frequency range. And as compared to that, we have FHSS, wherein the frequency keeps hopping at different values, and hence the signals, whenever the user or some intruder is trying to get into the system using that particular frequency, the frequency would change immediately. So this is how it is more secure as compared to the narrow signals that we had, and we were trying to broaden those signals. Now this is the whole concept about frequency hopping spread spectrum, wherein the data is modulated using different frequencies, and after every some time the frequency hops, so that the signals will be modulated using that frequency. This is the whole concept about frequency hopping spread spectrum. I hope you are clear with it. If not, you can contact me. But until then, keep learning.